All right, so with this, we are looking at inconsistent and dependent systems. So we could solve the matrices because that's what you would do, but we've covered that in the previous ones, and so I really wanted to focus on some of the inconsistent systems that we get. So the first thing we can get is a system with no solution. And this is after we took a system, we made the matrix, we did all of the row work, and we got down to something that looks like this. So if we get to something that looks like this, it can't happen. We can't get the 1 right there. We ended up with all zeros. And that means that if we put this into a system of linear equations, like we have been doing, we would get 0x plus 0y plus 0z, which is equal to 5. Well, that can't be true. It's a false statement because 0 cannot be equal to 5. So that means that you don't have a solution there. And that's if you didn't do any errors. Now, a system with infinite solutions, you would get something that looks like this, where you end up with all zeros at the bottom once you've done all your row operations. Well, this makes sense. If I have no x's, no y's, and no z's that are all 0, that's going to be equal to 0. So 0 times all of them, that makes sense. It's going to be 0. It's a true statement, and that'll be true for any x, y, and z. What you'll do is drop the last row, so you'll only do the first 2 rows for your matrix, and then the system will look like this. X minus y minus 2z is equal to 2, and y minus 10z equals to negative 1. Now what we're going to do now is solve that in terms of z. So I'm going to actually do the work for that. If you're in my class, I have it typed out for you, but I want to make sure you understand what you're doing with this. So if we have our system, so this is 6.2, if we have x minus y minus 2z is equal to 2, and we have y minus 10z is equal to negative 1. I want to solve in terms of z for each part. So what I'm going to do is take each equation, and I want to solve in terms of z because both equations have a z. They do not have both an x. And because z would be our bottom part here. They do both have a y, but we're going to do it in terms of z. All right, because we can't do another equation where we can solve just for z, so that would be the reason. We can do an x equals, we can do a y equals, but we need that third equation, and we don't have it because it went away from all the zeros. So we'll have y minus 10z is equal to negative 1, and I want to solve in terms of y, in terms of z. So I'm going to add my 10z over, and I get y is equal to 10z minus 1. Now I want to solve x doing the same way. So I'll take the first equation of x minus y minus 2z is equal to 2, and I need to solve it in terms of z. But I have a y here as well, so I need to substitute in what y looks like. So x minus 10z minus 1 minus 2z equals 2. So now instead of y, I have 10z minus 1. So I now have x minus 10z plus 1, distributing the negative sign, minus 2z equals 2. Combining like terms, I have x minus 12z plus 1 equals 2. And now I need to solve for x and with everything else on the other side. So I'm going to add 12z and subtract 1, and add 12z and subtract 1. So now I end up with x is equal to, I have 12z and 2 minus 1 would be 1. So I have my y and I have my x in terms of z, because then I can write my solution. So the solution would be my x is 12z plus 1. My y is 10z minus 1, and then I have z. So then I can pick a value for z and plug into the other equations. So doing that, if I picked z equal to 1, I plug in 1 for the x equals 12z plus 1, and I plug it in for the y of 10z minus 1. And as I plug in 1, it solves down to be 13 and 9. So this is an order triple. That is true for our z equal to 1. On this one, if I do z equals negative 1, I end up with x equal to negative 11, and y is also equal to negative 11. And my z is still equal to my negative 1 that I chose. So with that, you get another order triple. So that just gives you some order triples that work for it, but the solution you would type is going to, into your homework, is going to be this. But you can plug them in to actually see an order triple that works. And the point of this section is to understand what do I do and what do I recognize when I get those inconsistent values for my matrices, when they are not just a regular system like we've solved before.